Okay, so today we're going to be looking at diverging mirrors or convex mirrors. So two names, same thing. So these mirrors don't cave away from you, they round towards you. So in this case, if you look at the mirror, here's the mirror. The reflective surface is right here. So it curves towards you. And so these mirrors will always produce a virtual image, is similar to when we did the plane mirrors, the flat mirrors. So it gives the illusion that the rays originate inside the mirror. So to do these ray diagrams is a bit different than what we were doing yesterday, but you're still going to say to yourself, parallel focus, focus parallel, because again, that's what you're going to be using the vast majority of the time. The odd time when you can't use that one, you will probably use the fourth one where you reflect the ray to the vertex and bounce it off using angle of incidence equals angle of reflection. So you might find all these rays a bit confusing here. Here's our incoming rays. Notice that our image is behind the mirror as opposed to in front. So we have our focus and our center of curvature behind the mirror and our light rays coming from the front. So as happened yesterday or the day before, my program made a mess of these ray diagrams. So you're going to have to bear with me here as I try and draw it. That is the worst straight line ever. So I'm going to have the light rays coming in this from the left of the mirror as opposed to the right, which the diagram above shows. So you're going to have focal point and center of curvature behind the mirror. So what you have to do is always extend your reflected rays behind the mirror, okay? So again, you're going to start out with, okay, I'm going to go parallel focus. So you go parallel, draw your arrow, and then focus. Now, the light ray isn't actually behind the mirror, so we're going to use a dotted line. So parallel focus. And then what you do is your reflected ray it bounces off the mirror exactly the same. You're just going to carry on that reflected ray. That's terrible. Okay. So there's parallel focus. Okay. So the focus is behind the mirror. You have to make sure you use dotted lines for that one and use arrows on your light rays because the real light rays are here. Okay, these are the real light rays. These are what is actually happening with the light ray. It's obviously going to bounce off the front of the mirror, but we're trying to find the image, which is virtual, so it appears to be behind the mirror. So that's ray one. You're going to do parallel focus. Okay, now I'm going to erase all this because I don't have enough room to do the next one. Okay, so the next one, as you can guess, is going to be focus parallel. So you've got your mirror, you've got your focus, you've got your center of curvature. Okay, now your initial ray, and you're going to use a ruler, you're going to angle that incident ray towards the focus. So I don't have a mirror, so I'm going to have to estimate here. Here's my original ray. And then the reflected ray, remember the reflected ray is the one that you bring behind the mirror, okay? So we have focus and then parallel to the principal axis. So that reflected ray is going to bounce straight back. Those are the real rays. But the one you draw behind the mirror is dotted and is reflected, is the reflected ray. So it's the one that bounced off, the one we just drew. So that's going to be parallel. Okay, so we have, in this case, going towards the focus and then parallel. Focus parallel as opposed to parallel focus. So again, keep saying that in your head. You'll be good to go. Okay, the next one. So the third type you can do. similar. Okay, so we have our focus and our, this is center of curvature and back. So you're going to go towards the center of curvature with your incident ray, your first ray, which is going to, let's see how I did. See, I don't have a, oh, not bad. I'm going to move my center of curvature. So you're supposed to go right towards the center of curvature, and then it's going to reflect right back again. Okay, again, I don't, it's not my favorite one. So I always use 1 and 2, and if I can't use one of those, I just like the third of the fourth way, which I'm familiar with because of plane mirrors. So, focus, center of curvature. So remember, the only thing you extend is the reflected ray, not the incident ray. So I'm going to draw my incident ray going towards the vertex. Whoa. Towards the vertex. And then it's going to bounce back. Angle of incidence equals angle of reflection. The principal axis acts just like a normal. So using a protractor, you would measure that angle and bounce it off. Now remember, the ray that's behind the mirror is an extension of the reflected ray. So I'm just going to extend that reflected ray out. Okay. So there are your 4 types of ray diagrams you can do. Remember, you only need 2 to get a good intersection point. But sometimes you can't use 1 and 2. Oh, how unfortunate. I was hoping. Let's see, are the rest maintained? That's not going to matter anyway. I have no idea why it does this. Anyway, and I can't even erase it to fix it, but that's okay. I'll draw one in. It's messy, but hopefully you get the idea. So I guess I'll use this one, the mirror that's been moved very weirdly over here. So I'll draw a principal axis through this mirror. You're going to have to ignore this other line. I have no idea where it came from. So I'm going to put in my focus and my center of curvature. So locate the image for each convex mirror. So it's convex, and again, so what you're going to do, oh, I need to draw in, I'll make it red or orange just so it's similar. Here, I'll put this here is my object. Okay. So to reflect it, I am going to do, and of course you're using rulers, you're using protractors, all that good stuff. You really do have to do your parallel line very parallel to the principal axis. So I am going to do parallel focus. So I'm going to go parallel and then focus and dotted line. So my reflected ray, I can't even draw it. It's going to come back like this. So incident, reflected. And now I'm going to do focus parallel. So I'm going to, I don't have a ruler, so I'm estimating. You never want to estimate. You want to use a ruler. That's how we get accurate here. But if I laid a ruler on this, I don't even know what would happen. So I'm going to go towards the focus now, and you're going to use a ruler to do that. So your incident ray, you're going to go focus. It's going to hit the mirror here. And then it's going to bounce back parallel. That's your reflected ray, the parallel one, to the principal axis. And remember, it's the reflected ray I bring straight. It's terrible. Okay, so my intersection point appears to be right here. So I'm going to draw that in. And okay, what a mess. Oh no! Let's see if I can no, okay. Okay, so how would I describe my image, which is, you know, right here behind the mirror? How would I describe that? Well, I don't know. You're going to have to actually measure yours. What I see is it's smaller. Got that right. Upright, yes. Closer to the mirror than the object. Sure is. In virtual, yay. So that's it. So that is using that is a convex lens, a lens that bulges out towards you as opposed to caves in away from you. So for today, before we get on to some more mathy stuff, I would like you just to, I'm going to give you a sheet, Convex mirrors, and I just want you to practice your ray diagrams and then upload it.